So now we're going to get into a discussion concerning electronegativity and polarity of covalent bonds. So let's get started. So let me go here. And when we talk about the electronegativity of an atom, it is basically a measure of the ability of an atom to attract shared electrons to itself. So if you have two atoms connected to each other, what you'll find in some cases is that both atoms will have different levels of attractiveness or attraction to the shared electrons. And that attraction to the shared electrons would be the electronegativity. And it says here electronegativity is related actually to two particular thermodynamic quantities, ionization energy and electron affinity. And the greater the electronegativity of an atom in a molecule, the more strongly that atom attracts electrons in a covalent bond. And what you'll find is that if you look at trends in the periodic table, you'll find that generally the electronegativity increases from left to right of any period and also increases from bottom to top of any group. And a guy by the name of Linus Pauling, he came up with a table, a scale actually, of electronegativity values based on what we said before, ionization energy and electron affinity. And this is what he came up with. It's a 4-point scale where 4 would be the maximum electronegativity possible, which is the case of fluorine. And then we have other values that are given here, all right? So as you can see, as I said before, going across a period, the electronegativity increases, and going down a group, the electronegativity decreases, all right? So this table actually is available in Canvas that I've posted in, I've posted in Canvas. It's a part of a document which gives a lot of information, tables, periodic table, and so on. So this is available in Canvas for you to refer to in test time and so on. Okay, so it is known that the three most electronegative elements would be, actually the four most electronegative elements would be nitrogen, chlorine, fluorine, and oxygen. These are the most electronegative elements, all right? Okay, so what we can do is make predictions as to the order of electronegativity based on the periodic table, right? So if you, let's look at this example right here. So this question is asking that you're to basically arrange these sets of elements in order of increasing electronegativity. So you're starting from the lowest to the highest, right? So the first in this series is chlorine, magnesium, and silicon. So let me get out of this here, and let me get to my writing pad here. Let me clean this up, and let me write down the elements, which would be chlorine, magnesium, and silicon, right? So if you consult the periodic table, and I have a copy of the periodic table here somewhere. Let me go here. Okay, so here's the periodic table, right? You'll see that, okay, the three elements are chlorine, silicon, and magnesium. They're in the same period, right? So basically, magnesium would be the first element in the series, right? Would be the least electronegative element. And then going across, the next electronegative element is silicon. And then going across, the next electronegative element is chlorine. So the answer for this series would be magnesium would be the least electronegative element, followed by silicon, and then followed by chlorine, all right? So that's basically the answer for A. Now in the case for B, you're given arsenic, nitrogen, and phosphorus, right? So if you consult the periodic table, arsenic is here, nitrogen is here, and phosphorus is here. Remember, going down a group, the electronegativity decreases, right? So arsenic would be the least electronegative element, followed by phosphorus, followed by nitrogen. So the answer here would be arsenic would be the least electronegative element, followed by phosphorus, and then followed by nitrogen, all right? And then in the case of C, they gave you arsenic, selenium, and antimony, all right? So going back to the periodic table, okay, let's look at these elements. So arsenic is here, selenium is here, and antimony is directly below arsenic, right? So I would say that in this case, antimony would be the least electronegative element because going down the group, it would be decreasing, followed by arsenic, right? And then now, because selenium is to the right of arsenic in the periodic table, selenium would be the most electronegative element, all right? So the answer would be arsenic, selenium, and then antimony. All right, let me just check something here just to be sure. Actually, antimony would be the least electronegative. I'm sorry. So let me erase this here. So antimony would be the least electronegative, followed by selenium. Hold on. Antimony, arsenic, and then selenium. I'm sorry. Antimony, arsenic, and then selenium. All right? Okay, so that's basically the answer for C. All right? Okay, so going back to the PowerPoint here. Okay, so I'm going to stop the video here, and then we're going to look at the relationship between the electronegativity difference and the type of bond that's associated with it. All right, until next time.